So this will be the fifth rule for the technique of differentiation. The fifth rule, the name of the fifth rule will be called quotient rule. So as the name suggests, it will be a fraction. So as the name suggests, there will be a fraction. So when you see a fraction, doesn't mean that you will always go for quotient rule. There's a lot of misconception. So when you see a fraction, the condition will be the numerator must contain x. The denominator must also contain x. So both the numerator and denominator must contain x. So what happens when one of them doesn't contain x? We do not use quotient rule anymore. Okay, so if you see a fraction, it must satisfy this condition first. And in this case, the numerator is called u, the denominator is called v. So don't change the formats, otherwise you'll get confused. So the quotient rule is a bit complex. The quotient rule on its own has already gotten a fraction. So if you observe the formula here, the denominator is v squared. The denominator is the original, it is the square of the original denominator. So the numerator is the one that looks a bit complex. So we will have the function first, and then we multiply by du dx, and then we got to subtract u multiplied by dv dx. So it also, you might find the numerator looks a bit like the product rule, but it's not. The product rule is the addition. So here is the subtraction. Okay, so again, there are two cases. The first case is where there is no square root. So actually, if there is no square root, it's actually pretty easy. It can be quite fast, and if you are very used to it, it can end up like quite mental. You can mental out quite a bit. So this is the numerator, it contains x. The denominator also contains x. So the numerator is u, the denominator is v. So again, if you look, it looks like I'm doing my normal, my mini differentiation. So by now, I shouldn't need to elaborate on the mini differentiation. So I'm going to explain how are you going to put into the quotient rule. So as I mentioned just now, if you are applying the quotient rule, the denominator is the original denominator with a square. And then for the numerator, this is the function v. So the function v is here, multiplied to du dx. And then you are going to subtract the function u, which is just the x, multiplied with du dv dx. So I'm literally, once your mini differentiation is done, you are plugging into the huge formula. But then if you look, it's actually quite easy. You just have to expand out. Okay, if you expand out, you got x plus 1 minus x. So that's how I got the 1. So if you realize, right, it's actually much, much easier. Okay, at this moment, there will be some students who will strongly prefer product rule. So there will be students who prefer to look at it this way, and then they make it into a product. So you can do that. If you're going to do the product rule, this will be the u. This thing with the negative power will be a v. So if you want to change this question to a product rule, yes, you can. But it will be more complex. If you want, right, you can try the product rule. You will still get the same answer, but you find it more troublesome. So actually, if it's like this kind of fraction, I suggest you just use direct quotient rule. That will be so much easier. Okay, here comes the next situation. So it's always the square root that creates the issue. So in this case, my numerator is the square root. So my numerator is the square root. My denominator is quite a normal looking function. So again, do your basic mini differentiation first. So as you do the mini differentiation, the one with the square root will be a power half. So you got to do the bring down power minus power. So to some of you, if your indices is not so good, you will be mind blocked by the negative half. So the negative half is actually square root. So that's how I end up with this. So again, right, this part is very important. You need to simplify into a proper square root so that it facilitates your simplification process later on. So for the function v, I think it's a lot easier. That is just rule number 1 and then rule number 2. So here the challenge will be you are going to plug into the formula. So I'm going to write the quotient rule so that you can visualize what is being done. So it's always start with v and you are subtracting. And then there is a denominator which is the original denominator square. So take a look. This is the original denominator. Then you square the original denominator. So the quotient rule starts with v. So you take the function v and multiply to the du dx. So this is v. This part here is the u dx. And then you're going to subtract u times this. So that is the square root multiplied by 1. So that's how I got the minus square root. So once you successfully input your mini differentiation into the formula, so everything, the differentiation is done already. So the complex part is quotient rule itself is a fraction, but yet I got another fraction here. So it's actually look very, very complex. So what will be the technique? The technique will be, okay, before we apply the technique, make sure this follow the numerator. So you actually got a small fraction. You got a small fraction within a big fraction. So you multiply by the small denominator. This is what I call the small denominator. So what do I mean by I multiply throughout? Okay, so let me show you. So this fraction, if you multiply by 2 root x, it will cancel. And you are left with 1 plus x. And this, if you multiply by 2 root x, you get a 2x. So here you multiply by 2 root x, then it just be 2 root x times the original fraction square. So you realize that now you only got a huge fraction. So which is very easy to simplify. You just need to simplify the numerator. Okay, so again, there are two categories for you to take note. And what are the conditions? The numerator and denominator must contain x. So this question, usually fraction can change it up and make it into a product rule. But I will strongly advise that it will usually be longer and you are actually very subjected to careless mistake.